So I'll start just with the introduction. So Mark Hogsett with Rendered AI. If you haven't heard of Rendered AI, we're a synthetic data generation platform, and we specialize in generating synthetic imagery for use in computer vision applications. One of the things to look at when you think of Rendered AI, don't think of us as necessarily a synthetic data provider. Truly look at us as a platform that delivers synthetic data generation capability into the hands of your users. A lot of the investments that we're making are to simplify the platform so it can be used by a broad user group, so that you don't have to have the computer vision engineer. You don't necessarily have to have the domain expertise on the individual sensor in order to build and generate viable synthetic data.
While you're spinning up, can you just explain a little bit the difference between the way you guys take a physical, physics model of the data that you're generating?
So we'll say physics-based synthetic data or engineered data, versus generative AI. And I do have a slide because it's a question we get all the time. So from a physics-based, we choose simulators that relies upon the laws of physics and acts within the laws of physics. So we reduce it down to mathematical problems on how we generate the data so that the synthetic data, whether it's hyperspectral, multispectral, SAR, X-ray, the simulators we're using are accounting for the laws of physics and how it's interacting with atmospherics, how it's interacting with texture, how it's interacting with the material properties of individual objects so that you can produce imagery realistic, true to the sensor that you're needing to develop algorithms for. All right, so Rendered AI. Just gave a slight overview of who we are. This is actually an infrared synthetic data image generated from our platform. And what you'll see from all the images, with exception, and I'll point it out, with exception of one slide, all the images that you're going to see have been generated from our platform. Gave a brief overview of who we are, Rendered AI. We are a small business based out of Seattle, Washington. Our founder, Nathan Kuntz, is based outside of Seattle. So if anybody's in the area, please get with me. Nathan is happy to do coffee or lunch. This is a wordy slide, but a lot of times I put this in there more if the slides are handed out. But I just want to emphasize what we're obsessed with is the platform approach. And so when we look at synthetic data, what we're looking at is what is that platform, what is that data layer that's needed in order to build effective synthetic data. So whether it's generating 3D models, how are we what's the new and up and coming text to 3D assets that we can leverage and deploy on the platform. What is the next and best breed of simulators? And so that can be something like DeerSig or NVIDIA Omniverse. It also can be platforms like Unity or other, gaming engines that are used to generate synthetic data. We're agnostic to those because what we really want to do is bring those onto the platform, automate and simplify the use for our end users. Just for the themes, one of the things that surprised me, and I actually did this slide probably about 6 months ago, when it was looking at what is the state of AI, both within the US government, but more globally, one of the things that was more alarming was just to see, the adoption of AI broadly across the globe. So this isn't just a China problem or a Russia problem or Iran. It really is a global initiative with individual nation states and also illicit and adversarial entities that are investing in AI and are deploying it today. And it's just not, who's developing the AI strategy, but when you go and look and start pulling from these different companies, it is very interesting. I wouldn't say frightening, but it is where the world is moving. I won't spend too much time, but the world is becoming more complex. And especially when you look at the new space architectures, the Space Force is developing, when you start looking at, our adversary, one of the speakers earlier today, If China were to produce 2 billion uncrewed systems, the only way that you're going to be able to effectively deploy those is through autonomy and AI and through automation. So we as a nation force, how do we start accounting for this? Especially when you get into the battle space, right? The battle space and the environment is going to change. And when you look at, AI, and it's, a saying that we use often within rendered AI, is AI is written, the code for AI is written with data. And so your current AI systems, the autonomy AI systems, they're dependent upon the data that was used in that algorithm. But once you start getting into the battle space, especially when you start dealing with adversaries that understand AI and how you're implementing it, there's physical changes they can do to the objects of interest. There's also data poisoning they can do through adversarial machine learning, perturbance of images that are being used. So if the adversary knows that how our AI systems work, they can take active measures to defeat those AI systems. So the need to have constant surveillance then around how your AI is performing is paramount. And how can you make data a dynamic asset and tune it in pace with the operations? And one of the ways you can do that is synthetic data. And so that's really gets into then, how synthetic data isn't a panacea to all the problems. Real data will always be needed more so than the synthetic data. But at those times where you need to test the model performance and the performance envelopes of that data, that's where synthetic data can come into play. Considerations for synthetic data. More times than not, most of the customers and the clients I end up talking to, they've had a bad experience with synthetic data. And a lot of times it's because they've started with generative AI. And so generative AI, because it is it's an algorithm, it's dependent upon the data that was used to train it. A lot of times within computer vision, if you're using generative AI to generate your synthetic data, ultimately you're going to lead into model collapse. And that's because the AI is going to struggle, to deal with new use cases that you want to feed into the system. So this is where a physics-based approach, an engineered-based approach to synthetic data matters. When you look at the use case, another place where people tend to fail with synthetic data, they ask it to do everything, but it's really taking a step back. Do they have a well-defined use case? Do they have a well-defined objective for the algorithm that they're looking to train? What type of sensors, what type of 3D assets, what type of scenes that need to be generated? And that's typically where we start the conversation. Then you move into the accurate simulation based upon the use case that you need. Do you have the right simulator? And it could be something like Unity, or you may need DeerSig if you want to do hyperspectral, multispectral. We also have SAR. And then you get into the accurate digital twin, so the buzzword of digital twin. So as long as we have the technical specifications of your sensor, we can then model that on our platform. Cloud tooling. A lot of the limitation of synthetic data is what is your GPU, what is your compute available to you? Can you effectively manage that? And can you effectively identify the resources that you need? Because that is going to be the biggest limiting factor on how quickly you can generate large data sets. Domain matching and data cleansing. Rarely on the first iteration of generating synthetic data are you going to generate a viable data set that can be used to train a performant algorithm. It takes at least 3 iterations of adapting the imagery that you're producing to pull it in line with the sensor that you're trying to emulate. Where a platform helps benefit is you can capture all of that work, that knowledge management of what it took to pull that image, those 3D assets, the background scenes, how you're deploying those sensors, and you can reapply it time and time again. Effective CD model training. How quickly can you, once you produce the synthetic data, integrate that into your CV model so you can do the iterative testing? Well-defined experience with CV model. How do you test, is the model that you're using to detect tanks, say in Garrison, how well is it actually detecting the tank, versus detecting the parking lot that those tanks are at? So what they've done, and what's the best use case for synthetic data, is take the object of interest and put it in water, put it in areas that you normally wouldn't see it, to force the model to train detection of the object of interest versus it being biased, to the surrounding. Other ways that you can use synthetic data is through the generalization of models. So you may have a model that's really good at detecting an Iranian UAV in a desert. What's happened when that Iranian UAV now shows up over a forested space or in an urban environment? There's going to be some degradation to the performance of that algorithm. You can use synthetic data to change the domain background, the scene background, in order to help improve and generalize the models. Okay, then that gets into data as a dynamic asset. So current data, when you image it, it's static data. You have to go out and collect, you have to label it. With synthetic data, it becomes a dynamic asset. So as the real world changes, you can change the synthetic data. This gets into integrated pipeline. Right now, we have SDKs and APIs. The reason I asked the question about agentic AI in MCP servers, that's what we're investing in, because I think that's where the DoD Intel community is going. So we shouldn't have to have people actually write code for API integration and the translation of the IP or the data structure or schema. We should be able to use these agents to write that code for us in order so that you can have rapid development of synthetic data, and you can have the synthetic data tuned in line with your AI as you're tuned in within real world situations. Next slide. It's DoD, so we have to throw out policy, zero trust. So commercial imagery, NRO has done a wonderful job at developing with their different commercial layer purchases. Most commercial companies that have data or labeled data, a lot of times because of the cost, they outsource it. And so even though it could be a US company, but if the data labels have been generated from a foreign country, how much trust do you have around that data? The same also goes into, if you're buying commercial algorithms, how can you test and do a forensic of those algorithms to ensure that they haven't been tainted? And then that's the slide on generative AI. If you go down one. So in addition to algorithm training, next generation sensor, we worked with Planet on their Tanager constellation. So we generated synthetic data that they were going to be true to their multispectral or hyperspectral for the Tanager. And so they can pre-train an algorithm before the sensor was deployed. So as soon as the sensor started collecting data, they actually can have detection models running against it. Exercise support, right now, a lot of the MN is textual. If you suspect changes in TTPs, generate synthetic data. And then imagery analysts, the mammals, they matter. How can you better train them on data that is going to be realistic to what they see? And with that, I'll take questions.
You mentioned the possible use of if an adversary knows that you're relying on close imagery, for instance, that's a vulnerability for your modeling.
Not for our modeling, it's a vulnerability to the models.
Right.
Yeah.
In general. And for all the talk about AI from sort of from this side of things, then the sort of disinformation campaigns we've been hearing about, there has been a whole lot of overlap between the two when it comes to discussions. Is there a use case for this sort of technology for kind of reverse engineering, say, disinformation of our own and generating the sorts of imagery or just data in general and releasing the ecosystem if we want to?
I think there's, to restate it in a different way, there is both offensive and defensive adversarial machine learning. right? There's one, we have to protect against what adversary is doing. How do you detect images that have been perturbed, so that they will disrupt or corrupt how an algorithm is changed. But from the same token, we have that same capability. And it's some prior work within cyber, was somebody from Cybercom, basically, if I can penetrate their system, there is a brief moment where they can penetrate mine. So I think there is offensive and defensive side to AML.
Is it a given that you do video as well?
We do F&V. It does take a little bit more time, and what we will generate is like 3 to 5 second clips. So think of it's training the algorithm, and similar to SAR, we do full scene SAR, but a lot of times it's the objects of interest that we start with, and then there's some technical difficulties around SAR and the shadowing, and how when you start inserting different 3D assets within a SAR image, how they can wash it out. Yep.
The method that you use to generate the image, that introduce some constraints on the computer. They're applying them.
Can you be?
So if you're generating a full video, right? You've got your kind of physics-based measure, right? Am I able to do that at 30 frames per second, or?
You can, and it's basically we'll be able to emulate. Pretty much any sensor that's imaging, whether it's image or FMV. The question is time, because there is going to be some tooling involved, and that's what we found. Like every company who has computer vision, for the most part, think of all the large traditional defense, even the smaller, they're using synthetic data, but it's very inefficient, very time consuming, and you're repaying that cost every time because you have the individual teams are building their own scenes. And that really is the benefit of the platform. Once it's done once, you can recapture and reuse at an enterprise level, it is at an individual team, but the team benefits the whole.
Yeah, that's kind of what you say, because a lot of times when we talk to folks, they're like, when we try to do the synthetic data with them, they're just like, no, like just capture real data. It's far more resource efficient to do it.
And their use cases, and that's absolutely true, but you still have to label it, and you need to make sure the humans or even the algorithm is correct. So, it's not the panacea for everything, but it can get you far.